Our next speaker will join us from Zoom. He's Andreas Hütteman, Chair of Theoretical Philosophy at Cologne, who will talk to us about empirical access to modal structure.
Yeah, thank you very much for the invitation and for organizing the whole thing. Yeah, I'm going to talk about empirical access to modal structure. This is the overview. How much time do I have to talk?
Until 11, including Q&A. Since we're 5 minutes ahead of time, you can freely speak for 35 minutes, and then we'll have 30 minutes for Q&A.
Okay, good. Yeah, first, humanism and non-humanism about laws. Non-Humeans argue that there is irreducible modal structure that accounts for modal phenomena such as lawhood. Armstrong, for instance, says, suppose it to be a law that F's are G's, Fness and genus are taken to be universals. A certain relation, a relation of non-logical or contingent necessitation holds between Fness and genus. This state of affairs may be symbolized as NFG. Dispositional essentialists such as Bird appeal to essences of properties in virtue of which a certain behavior of systems is metaphysically necessary. The essences ensure that the behavioral regularities in question hold with necessity and thus support counterfactuals, for instance. And a further example is provided by Mark Lang's theory of laws. Subjunctive facts are ontologically primitive and responsible for laws. How is belief in these entities, necessitation, justified? Here's what Armstrong has to say. According to the regularity view, the law is exhausted by the fact that the observed F's are G's and that the unobserved F's are G's. I hold, however, that the law involves an extra thing, some further state of affairs. The presence of this extra thing serves first to explain why all observed F's are G's, and second to entail that any unobserved F's will be G's. This postulation of the extra thing is a case of inference to the best explanation. And similarly, Lang's introduction of irreducible subjunctive facts can be understood as proposing an inference to the best explanation, at least that is what he suggests. The case of Bird is a bit different. He doesn't like inference to the best explanation, but if you are not Bird and you want to defend a view like Bird's, you probably would go for inference to the best explanation. By contrast, Humeans reject the appeal to irreducible modal entities. One reason is that Humeans doubt that we can ever know whether there are such irreducible modal entities. Instead, Humeans defend the thesis of Humean supervenience, which you all know, so I don't have to read this. If modal phenomena can be fully explained in terms of patterns of the Humean mosaic, these phenomena are within our experiential reach because they reduce to facts which are within our experiential reach. So Humeanism says something like this: because fundamental modal structure, if it existed, would not be within our fundamental experiential reach, we should refrain from postulating fundamental modal structure in order to account for modal features or modal phenomena that we seem to observe or assume. Instead, modal features of the world should be explained in terms of features that are experientially within our reach, i.e., it should be explained in terms of the Humean mosaic. Non-Humeans, by contrast, say the modal features of the world cannot be explained solely in terms of features that are experientially within our reach. Even though fundamental modal structure is not within our experiential reach, we need to postulate such structure in order to account for modal features, e.g. via inference to the best explanation. So what these two views have in common is that they assume that fundamental modal structure, if it existed, would not be within our experiential reach. And that's sort of the common assumption which I want to reject in this paper. Let me now turn to what has been called the access problem. Humean supervenience is an attractive view for Humeans because if everything else supervenes on these local matters, of fact and thus is nothing over and above these facts, then these structures are experientially accessible, provided the local matters of fact are. Ehrman and Roberts have argued that only if laws of nature supervene on the Humean mosaic can belief in laws be justified. We think they write that Humean supervenience, suitably formulated, is true. It expresses necessary conditions for laws of nature as such to be within our scientific reach. That is to say, the possibility of empirically justified belief of a law of nature, that it is a law of nature, depends on Humean supervenience. If not, if the laws do not supervene on the Humean mosaic, it is difficult to see what kind of evidence there could be for an account of laws of nature, say Ehrman and Roberts. Once we have granted that Humean supervenience is false, they say we are committed to the view that laws of nature are an extra metaphysical ingredient of the world, over and above the Humean base. What constraints could the Humean base then place on the laws? More recently, this line of argument has been generalized by Wolfgang Schwarz. If the world contains primitive modal elements, irreducible laws, powers, potentialities, or propensities, how could we know about them? Humeans have long worried that we could not. Put bluntly, the worry is that observation and experiment only tell us what does happen. They don't directly reveal what might or must or would happen under non-actual circumstances. If modal phenomena are reducible to facts about current events, then it is no surprise that observing occurrent events can give us information about modality. By contrast, knowledge of primitive modality seems to require an inexplicable leap from the observations of one kind of fact to conclusions about an entirely different kind of fact. Let's call this the access problem for non-Humean accounts of natural modality. Let us have a closer look at Schwarz's claim that observation and experiment only tell us what does happen. They don't directly reveal what might or must or would happen under non-actual circumstances. I will argue that there are two ways to understand this phrase. Both understandings will yield problems for the Humean. On a strict reading, what is directly revealed by observation and experimentation can only concern past and future events. Past and present events. Future events haven't occurred yet. Therefore, we do not have direct experiential access now to those regularities that are constitutive for Humean laws, because these regularities concern the whole Humean mosaic, and thus also may concern future events. On the strict reading, the regularities that are constitutive for Humean laws are now as unknowable as the extra metaphysical ingredient of the world over and above the Humean base. Ehrman and Robert do acknowledge that they face this problem, and so does Schwarz. He admits that most of our empirical knowledge rests on the a priori assumption that certain regularities in the observed part of the world continue to hold in the unobserved part. This assumption of timeless regularity of nature, as Beebe puts it, allows us to extrapolate from what we have observed to the unobserved part of the world. So we make inductive inferences. And that brings us to the more liberal reading. According to this more liberal reading, what is directly revealed are those events that are directly revealed by observation and experimentation in the strict sense, plus those events that can be inferred to via simple inductive practices based on the assumption of timeless regularity. Given the more liberal reading of what is directly revealed by observation and experimentation, it is plausible to argue that the entire Humean mosaic counts as directly empirical accessible, not just the past and the present. Let me say a few words about inductive practices, which I have appealed to here in contrast to abductive practices or inference to the best explanation. Inferences are often divided into deductive and non-deductive inferences. Deductive inferences are certain and non-ampliative, non-deductive, non-certain and ampliative, where ampliative inferences say something more than what has been said in the premises. Non-deductive inferences can be divided into inductive and abductive inferences. Abductive inferences are inferences to the best explanation and postulate unobserved causes or other explanatory features, while simple inductive inferences do not introduce new concepts or entities. That's how I use the notion of simple inductive inference. Okay, let me now show you that the access problem isn't necessarily a problem. We do have empirical access to modal structure, I will argue. And yeah, the claim I want to argue for is, in what follows, is that both on the strict as well as on the liberal reading of what is directly revealed by observation and experimentation, problems for the Humean conception of laws arise. The first part of the argument has already been made. On the strict reading of what is empirically accessible, Humean laws would become unknowable because an underdetermination problem with respect to the future course of events looms. The regularity that is constitutive for Humean laws would become as inaccessible as laws on a non-Humean conception. On the liberal reading, we allow for extrapolation via simple inductive inferences from the observed to the unobserved. That allows us to treat the future part of the Humean mosaic as directly revealed by observation and experimentation, and thus Humean regularities qualify as directly empirically accessible. However, if the Humean moves from the strict to the liberal reading of what is directly revealed by observation and experimentation, she is no longer entitled to assume that what is directly revealed by observation and experimentation is the Humean mosaic only. It turns out that according to the liberal reading, what might or must or would happen under non-actual circumstances can, at least in some cases, be directly empirically accessible. And the consequence is then that the Humean motivation for reducing modal facts to the Humean mosaic collapses, because from a Humean perspective, if modal facts are empirically as directly accessible as the facts of the Humean mosaic, there's no longer the need to argue that the former supervene on the latter. Okay, so that's the plan. Here's an illustration of how modal facts are directly empirically accessible in the liberal sense. And here I turn to Galileo's spokesman Salviati in the dialogues concerning two new sciences. He argues for the claim that bodies with different densities or mass would fall with equal speed in a vacuum. Here's the quote. We have already seen that the difference of speed between bodies of different specific gravities, that is, bodies with different mass basically, is most marked in those media which are the most resistant. Thus, in a medium of quicksilver, gold not merely sinks more rapidly than lead, but it is the only substance that will descend at all. All other metals and stones rise to the surface and float. On the other hand, the variation of speed in air between balls of gold, lead, copper, porphyry, and other heavy materials is so slight that in a fall of 100 cubits, a ball of gold would surely not outstrip one of copper by as much as 4 fingers. Having observed this, I came to the conclusion that in a medium totally devoid of resistance, all bodies would fall with the same speed. So that's an extrapolation to what would happen under counterfactual circumstances. Let me analyze this argument in a little more detail and sort of reconstruct it. Suppose we have a cylinder with height h and it's filled with some medium. We have the velocity of the falling object, and then there are two variables that Galileo is interested in, the density of the medium, dm, and the density or mass of the falling object, df. All of these quantities are measurable or directly measurable quantities. And Galileo is interested in the velocity of the falling bodies depending on the density of the medium and the density or mass of the falling object. So in the argument or around the argument, we can distinguish various kinds of inferences that play a role. One kind of inference is in fact not mentioned by Galileo, but I introduce it, which is Humean inductive inference. And the idea is that we have that we have one object with a certain mass, a df, the falling object with a certain mass or density f1, and then there is the density of the medium, and both are fixed, and we measure it. We measure the velocity at t1 and at t2 and t3 and t4, and then by inductive inference we can infer to what would happen under t5 or t6. That's simple inductive inferences towards the future. The next kind of inference is the extrapolation to the vacuum case. Here we have the velocity and a falling body, which is fixed, but the medium is not fixed, and we start with one sort of medium, and the density of the medium becomes less and less, and finally we extrapolate to what would happen if the density of the medium were zero, if there were a vacuum. And that's sort of an extrapolation to the velocity of a body with density f1 that it would have in a vacuum, and nothing, no sort of special causes or anything it's not an is introduced. It's not an abductive inference. It's sort of according to the classification I suggested. It's a simple inductive inference. And then we have the case that Galileo actually describes, which is that we have different falling bodies with different densities, f1, f2, f3, and it turns out that the velocity in the vacuum is invariant with respect to the mass of the falling body. So that's an invariance claim about a counterfactual situation. Okay, so the second and the third kind of inference give us direct empirical access to modal facts, to how systems would behave provided certain conditions were to obtain, and to invariance relations under counterfactual circumstances. So to sum up this part of the paper, either we choose a strict reading of what is directly revealed by observation and experimentation, then even the regularities that undergird Humean laws would become unknowable, or we accept a more liberal reading, which is, of course, the more reasonable reading, I would say, of what is directly revealed by observation and experimentation, and allow for extrapolation from the observed to the unobserved via non-deductive, non-abductive inferences. Then it turns out that we do have direct empirical access to some modal facts. So the Humean conception of laws either renders laws unknowable, or it turns out to be ill-motivated. What is better motivated is another account of law, namely an invariance account of law. And I will now turn to this invariance account of law. I will explain how those modal facts that we do have direct empirical access to suffice to account for the modal features we generally attribute to laws of nature. On the one hand, the project is motivated by Humean concerns. It tries to reduce modal features of laws to features that are within our experiential reach. On the other hand, there is no attempt to reduce modal facts to non-modal facts. So what are the modal features of laws, or some of the modal features? Roughly, a modal aspect of the behavior of systems, or the laws that describes this behavior, is an aspect that concerns not only the actual behavior of systems, but also possible behavior or behavior that obtains by some sort of necessity. For example, laws tell us how systems might or would behave provided certain conditions were to obtain. And second, laws tell us how systems are constrained to develop, for example. And that's usually what we mean by the fact that laws constrain the behavior of system, or yeah, that's what we usually mean by natural necessity. I have already argued that claims falling like one are in principle within our experiential reach on a liberal reading. And I will now turn to two. And that's, I will now turn to two. The claim is that constraint or natural necessity can be spelled out in terms of invariance relations. several people have argued along these lines, Sandra Mitchell, Woodward, and so on. The general idea is that natural nomological necessity boils down to the fact that laws cannot be broken. Take, for instance, Newton's second law: everybody behaves according to the equation F equals ma. It is nomologically necessary in virtue of the fact that there is nothing that can or could be done by any system, including experimenters, to render the second law false. The claim that laws are nomologically necessary is best understood as an invariance claim. So that's the claim. What is an invariance? Here the general idea is that there are changes or transformations, but something remains the same or robust or stable while these changes do or might occur. An example is Galileo's law of free fall. Free-falling bodies fall according to the equation S equals a half gt square, which is invariant with respect to the mass of the falling body. And we have seen evidence for this. At least we have seen evidence for the claim that all bodies fall in a vacuum, that the velocity is independent of the mass of the falling body. That's one kind of invariance. I will distinguish various kinds of invariance right now. There is invariance with respect to initial conditions. Take again Newton's second law. Despite changes in initial conditions, i.e. in the value of the force, the law equation remains, and the law equation is the equation F equals ma, remains the same for all values of the initial conditions. Another example is Galileo's law. Despite changes in initial conditions, for example, the value of S, the law equation remains the same, at least for a certain range of values for S. So invariance may be more, that is a matter of more or less. The law equation is invariant under certain changes of initial conditions. And that's the first sense of invariance. The law equation holds independently of the values of the initial conditions. Second sense of invariance has to do with features or properties of the target systems, of those systems that fall under the laws. The law equation is typically invariant with respect to some features of the target system, which are therefore not explicitly mentioned in the law equation typically. For example, in the case of free-falling bodies, the color, shape, and the mass of the bodies is not mentioned. And that's an indication for the law equation being independent of these features or invariant under changes with respect to these features. The same holds for lower level or constitutional properties. For instance, when in the case of the ideal gas law, the molecular structure of the gases is not mentioned because the ideal gas law equation is invariant under changes with respect to the molecular structure. Okay, so this kind of invariance is closely tied to the process of modeling. I mentioned that. But the important point is this is sort of the second kind of invariance. Then we have invariance with respect to the behavior of other systems. So the second kind of invariance I looked at just now was invariance with respect to features of the systems we are interested in. The law equations may also be independent with respect to the behavior of other systems. Newton's law of motion and his law of gravity hold for the solar system, whether or not other systems in the universe undergo changes. Of course, the initial or boundary conditions of the systems under consideration may change due to changes of other systems, but the law equations don't change. Similarly, in the ideal gas law equation holds whether or not I'm on time when I go to the dentist or whether or not a certain tree in my garden loses its leaves. In the philosophy of science literature, there is one sense of invariance which has been discussed a lot and which I haven't mentioned yet. That concerns not the invariance of law equations, but rather the invariance of the solutions of certain equations. And that's sort of what I will briefly mention here, the fourth sense of invariance with respect to symmetry transformations. There are certain kinds of transformations of the initial conditions which lead to the same solutions of the equations. For example, spatial transformations in Newtonian physics have no effect on the solution of the equation. So if you just move around the system you're interested in space-time, everything remains the same, not only the law equation, but even the solutions of the law equations. In this case, it is not only the equations that remain the same, but also the solutions of these equations. Okay, and this is the kind of invariance that has been in the focus of the philosophy of physics literature, but it's not so interesting for me because it's not quite clear whether this kind of invariance really describes something in nature. This kind of invariance may simply be due to excess mathematical structure in the physical theories. For example, if absolute space doesn't, maybe it's this kind of transformation, a spatial transformation in Newtonian physics is simply due to the fact that there is an excess structure attributed to absolute space. And if you cut that out, then this invariance disappears. So anyway, all I'm saying is in philosophy of physics, there's much talk about this kind of invariance, but I'm not interested in this kind of invariance. I'm interested in the other kinds of invariance, which are invariances with respect to the law equation. Yeah, so to a few comments. The above is not meant to be a complete list of invariance relations. Maybe law equations are invariant with respect to other features too. All of these different invariance claims are empirically accessible. We can test whether and under which elongations Hooke's laws hold. So we can vary the initial conditions and see whether the law still holds. We can test whether or not color, mass, and shape are relevant or irrelevant in free fall, and the same holds for consecutive properties. And we can test whether or not the behavior of other system leaves the law equation unchanged. All of these, furthermore, all of these kinds of invariance relations allow for the law equation to be more or less invariant. And this, so the claim I hope to have argued for is that laws, the nomological necessity that we usually attribute to laws is best understood in terms of invariance claims that can be empirically tested. And so you have satisfied the Humean demand that you don't introduce entities that are beyond what your experiential reach, but you don't need. But that doesn't mean that you have to do away with irreducible modal facts, because these modal facts that laws of nature seem to appeal to have a great explanatory value, I would say. Okay. Worries, yeah. There are some worries that have been voiced with respect to invariance accounts of lawhood, for instance, by Stathis Psilos. Here's one worry. The accidental generalization, all taxis in Athens are yellow, is invariant under a certain range of interventions, since if you apply for a taxi license in Athens, your cab would have to be yellow. So if invariance is to be found in laws and non-laws, it should be at best a symptom of lawhood, but not constitutive for lawhood. Okay, here's my rejoinder. All bachelors are unmarried is invariant under many changes, but we don't mistake it for a law of nature. Why is that so? We do have an account of why this generalization has to hold, namely in virtue of how we use our concepts. This does not require attributing the invariance in question to nature, but rather to the use of to our conceptual, to the use of our concepts. Similarly, in the CAP case, we have an account of why this invariance holds, which does not require attributing the source to the invariance of nature, but rather to certain legal conventions, let's say. More generally, we are interested in how systems in nature could do or must behave in variances that are due to conceptual or legal conventions. We can sort out, it's not difficult to sort them out as sort of not being relevant. That presupposes a distinction of what is due to nature and what is due to conceptual or legal convention. But I don't think that's a problem for the Lawhood account. Maybe you disagree. And then there is a worry about circularity. In checking whether a generalization is invariant, we need to subject it to some variation changes interventions. What changes will it be subjected to? Those that are permitted or are permissible by prevailing laws of nature. But I'm not defining laws of nature as generalizations that are invariant with respect to all kinds of changes or with respect to changes allowed by the laws of nature. Rather, laws are those generalizations that are invariant relative to many changes where these invariances cannot be attributed to other sources such as conceptual or legal conventions. Again, this requires a distinction between nature, what is due to nature and what is due to legal conventions, for instance, but I don't think that's a problem for the Lawhood account. Okay, I have another 3 minutes and another 3 slides. Sorry for being so fast, that allows me to return to the access problem, and now I want to turn the tables and say that the Humean may have an access problem. Ehrman and Robert, as well as Schwarz, rightly insist on the requirement that an account of laws of nature must be able to explain how we have epistemic access to laws. The methods scientists use must be adequate to identify the lawmaker, what the lawmakers are. Whether anti-Humeans identify a modal phenomenon with the presence of some Humean, un-Humean whatnot, an irreducible law, a higher order universal, or whatever, they owe us an explanation of how our methods for identifying the phenomenon could serve as methods for identifying the un-Humean whatnot. But this requirement may backfire, at least for some Humean conceptions of laws. So consider Lewis's best systems analysis, which has been mentioned this morning already. A contingent generalization is a law of nature only if it appears as a theorem or axiom in each of the true deductive systems that achieves the best combination of simplicity and strength. Do we have access to the system that achieves the best combination of simplicity and strength? Probably not, but Lewis has a solution for this problem. The idea in Lewis seems to be that even if we do not yet have figured out this ideal theory, our current theories will approximate the ideal theory sufficiently close so as to allow us to come close to identifying the right kind of contingent generalizations as laws. However, this account of how scientists may have access to laws of nature does not work for those who worked before any theory like Newton's dynamics was developed and accepted. There was simply no theory to accept, to approximate the ideal theory. Take Galileo as an example. As the quotation above indicates, Galileo did not only accept his description of falling bodies and their behavior as mere truths about the world, he took them to support counterfactuals. And similarly, there's a famous argument by Leibniz, which contains the thought experiment about the conservation of vis viva. And there he appeals to Galileo's law, and he clearly assumes Galileo's law to support counterfactuals, otherwise the argument wouldn't work. So it seems fair to say that both Galileo and Leibniz treated Galileo's law as a law of nature. But as I said, there was no theory around of which it, other than the theory Galileo's law, but there was no other theory in which it was integrated either as an axiom or as a theory. So how were they able to identify laws without having access to anything that even remotely resembles the ideal theory? On Lewis' account, this remains a puzzle precisely because it's unclear how the methods that were available to Galileo or Leibniz would allow them to identify the axioms and theorems of the ideal theory, or of an approximation of the ideal theory. But there's no access problem for Galileo and Leibniz if lawhood is explained in terms of invariance relations. Thank you. Conclusion.